Hey y'all, Mr. Yisley here. So we're on to lesson number 6 in our chapter 5, all about exponents and polynomials. And up to this point, we've learned about 7 different exponential rules that we can use. 3 of which are really all the kind of the same thing. We're just really similar. But we've only dealt with problems to this point that you use one of those rules. Right? We didn't use any more than one. We only used one. Well, sometimes with exponential expressions, we end up with problems that require more than one of those rules. And so what we're going to talk about in lesson number 6, both in this part 1 video and then in the part 2 video, is how to use multiple rules with an exponential expression. Now, what I'm going to tell you is I'm going to give you a recommended order to solve. Now, I want to preface this by saying that this is not the only order that you could solve it in. There are multiple ways to do it. But this is the order that I've found to be the most effective for helping people make sure that they've completed all of the rules to get the exponential expression down as simple as possible. And so what we've done is we've created a 5-step process with this. The first thing we're going to do is we're going to address any 0 exponents. And we're going to use that 0 exponent rule, which says that anything to the 0 exponent is 1. And we're going to cancel that out if there's other things there. If not, we'll just turn it into 1. After we've done that, then we're going to go on to the second rule, which is the incorporation of the 3 rules that are all the same, which are our power rules. Our power of a power rule, our power of a product rule, and our power of a quotient rule. Now, all 3 of these, and the reason we incorporate them in the same is the indicator is the exact same for all of them that we need to use this rule. And the indicator, again, is 2 things. 1, you have to have parentheses. And 2, you have to have an exponent outside of those parentheses. So that's what we use to indicate if we need to use one of these rules. Now, in regards to how we do that, reminder that we then take the exponents that's on the outside and we multiply every single exponent on the inside, whether it's on the top or bottom of a fraction, or if there's no fraction, just every single part. So then we multiply. Then we're going to go on to our third rule after we've gotten rid of those parentheses using those power rules, and we're going to do the negative exponent rule. So remembering again that we take the negative exponent and its base and we move it to the other side of the fraction, and that allows us to turn it into a positive exponent. Then after we've gotten rid of all the negative exponents, we're going to use the product of powers rule. Now with the product of powers, we're looking for same bases. Right, so we're looking for same bases on same side of the fraction. All right, because as you've noticed on the examples, they're all basically in fraction form. So same bases on same side of fraction. So do we have the same base on the same side? Right, after we've combined those, and remember we combine them through addition, then we are going to use the quotient of powers rule. And when we do this, we have to remind ourselves that we are looking for the same bases on opposite sides of the fraction. So we're looking for same bases on the opposite side of fraction. And then once we figure out that we have the same bases, we subtract the exponents with the answer going on the side with the bigger exponent. Answer on side of biggest exponent that we started with. Now again, if you need refresher on these, all right, from previous lessons, please go back and take a look at those. But we'll be using all of these or checking for all of these in every problem as we go through. So those are the 5 steps that we're going to go through. So let's take a look at how that works in action. So the first thing we're going to do is we're going to create kind of a 5-column system. The first column is going to be directly over the original problem that they give us. Then we're going to have a second column right next to it. Third column after that. Fourth column after that. And then the 5th column right over there. Now the reason we have these 5 columns is we're going to do each one of the rules at each number that it lines up with. So in the number 1 column, we're going to check for 0 exponents. So example A says we have this exponential expression of parentheses 5xy to the third r to the negative third with a 2 outside the parentheses over 10x to the 9th, y to the negative 2, r to the 0. So in the first rule, again, we're looking for the 0 exponent. Well, I see that we have a 0 exponent right here, and it is attached to the r. So we've got r to the 0. Well, anything to the 0 exponent is just 1. And then 1 times anything is just itself. So as we've learned, this really just cancels out. So we no longer have that r, and I don't have any more 0 exponents. So I have completed that rule. So then in step 2, all right, we are going to look for our power rules. Again, remembering that our power rules are indicated by a parentheses with an exponent outside. So I look and see, do I have any parentheses with an exponent outside? I do, and that is on the top of my fraction, which means that I'm going to use those rules. Now, the bottom of the fraction does not have a parenthesis around it. It is on its own, so it is not going to change at all. So at this spot, underneath the number 2, I'm going to rewrite my exponential expression. Now, again, the bottom doesn't have any parentheses, so I'm going to leave it as is. 10 x to the 9th, and then y to the negative 2. Now, with the top where the parentheses lie, I need to make sure that everything inside my parentheses has its own exponent. So r has its own exponent of negative 3, y has its own exponent of 3, x doesn't have anything listed, so I need to put a 1. And then remember, 5 also has its own exponent. It doesn't have one listed, but it is also 1. Once I've done that, now I can multiply all the exponents inside by the 2 that's on the outside. So I'm going to multiply 5, and then the exponent of 1 times 2, so 5 to the 2nd power. Then I'm going to do x, so that is x to the 1 times 2 is 2, so x squared. Then the y, so y to the 3 times 2 is y to the 6th. And then last one, r to the negative 3 times 2 is r to the negative 6. And that gets rid of my parentheses. Now at this spot, again, anytime we've gotten rid of parentheses, make sure that if you have any numbers to exponents, that we simplify those out. So I have right here a 5 squared on the top, so I need to simplify that. Well, 5 squared means 5 times 5, which is 25, so I'm just going to cross that out and write 25. Now, third step, we are looking at negative exponents. So I'm looking at my exponential expression saying, do I have any negative exponents? Well, I see on the top I have a negative 6 exponent, and its base is the r. So I've got this exponent right here that's negative with a base of r. And then on the bottom, I also have a negative 2 exponent, and its base is y. Well, as we've talked about, to get rid of those, we need to take them to the opposite side of the fraction. So the r to the negative 6 is going to come down, and the y to the negative 2 is going to go up. Now, none of the rest of those things that are listed there have negative exponents, so they are going to stay exactly as they are. So on the top, I will still have 25 x squared y to the 6th over 10 x to the 9th right there. Now I need to make my changes. So I am going to move my r to the negative 6 to the bottom, and it's going to become r to the positive 6. And then I'm going to move my y to the negative 2 to the top, and it's going to become y to the positive 2. So now I've completed the third step, which was the negative exponent rule. So then fourth step, we're looking at product of powers rule. Well, remember, indicators for that is we have to have the same base on the same side of the fraction. So I want to look at just the top first and see if I have any. Then I'll look at just the bottom. So on the top, I see that I have y's here that are the same base. So with this rule, I am going to combine the y to the 6 and y squared by adding the exponents. Now that means my 25x squared doesn't change, so I'm going to rewrite that. So 25x squared is going to stay where it's at. And then y to the 6th and y squared make 6 plus 2 is 8. So this becomes y to the 8th. Now I'm going to look at the bottom. So when I look at the bottom here, I have no like bases, so it's going to stay exactly as it is. So it's going to stay as 10 x to the 9th r to the 6th. So then my last step, step 5, is I'm looking for quotient to powers rule. Quotient to powers rule says look for the same bases on opposite side of the fractions. So when I look at the top and bottom, right, I always want to start with the coefficients. And as we talked about before, we're looking at those two numbers, 25 and 10, and saying, is there a common factor greater than 1 that we can divide them both by? And there is. 5 goes into both of those. So I'm going to divide 25 by 5, and I'm going to divide 10 by 5. So 25 divided by 5 is 5, and 10 divided by 5 is 2. Then I want to look at the variables. Well, I see that on the both top and bottom, I have x's right here that are the same, all right? Or they're not the same, but they're both x's. The bases are the same. So that means that I am going to subtract their exponents, and the answer is going to go on the side with the biggest exponent to begin with. Well, I see that my biggest exponent is the 9, so my x's are going to end up on the bottom, and then 9 minus 2, because I need to subtract those, is 7. So I end up with x to the 7th. Now my y to the 8th, it doesn't have a like base on the bottom, so it's going to stay on the top. So y to the 8th stays on the top. And then my r to 6th on the bottom doesn't have a like base on the top, so it's going to stay on the bottom and stay as r to the 6th. So my final simplified exponential expression on this one is 5 y to the 8th over 2x to the 7th r to the 6th. All right, well, let's take a look at another example here. Sorry, that was a little bit cut off there on that side. Let's take a look at another example here. All right, an example B. So example B, we're going to follow that same method. Now on the first example, example A, we used all the rules in terms of all 5 of them. That will not always be the case. All right, now sometimes it will be, but sometimes you may only need to use 3 or 4 of the rules. You may only need to use 2, but we always want to go through that process of systematically checking for every rule to make sure that we don't miss out on simplifying something. So again, starting at rule 1, we want to check for the 0 exponent rule. So I'm looking at there saying, do I see any 0 exponents in this expression? I do. On the top, I have a 0 exponent, and it's going to an entire parentheses. Well, as we've talked about before, the base is always everything inside the parentheses. And so that entire thing is going to become 1. So what we really have right here is 14 times 1, because anything to the 0 exponent is 1. Well, 14 times 1 is just 14, so really this whole thing just cancels out. And all we're left with is the 14 on the top. Now I don't have a 0 exponent on the bottom, so I'm done with this rule. So the next thing I need to do is go on to the second one, which is the power rules. Again, remember, indicators of power rules are parentheses with an exponent on the outside. Well, I know on the top that I don't have that because all I have left is the 14, but I do see parentheses with an exponent outside of it on the bottom, so I need to use the power rule. So the first thing I'm going to do is I'm going to go ahead and move the 14 to the top of the fraction when I go to rewrite, because it's already on the top, but I'm going to rewrite it on the top. Then I'm going to do my power rule, but in order to do that, I need to make sure everything inside has its own exponent. So I see that y has its own exponent, x has its own exponent, but the 4 doesn't have an exponent listed, so I need to add in the 1 because this is 4 to the first power. Then once I've done that, I can do my multiplication, so I can do 4 to the first, or 1 times 2 is 4 squared. Then I've got x to the negative 3, well, negative 3 times 2 is x to the negative 6. And then my last one, y squared, well, y to the 2 times 2 is y to the 4th. So I multiplied my exponents. So at this point, I've done my power rule. I've gotten rid of my parentheses. But then again, I always want to check, do I have any numbers with exponents that I need to simplify? And it's going to happen at this step every time. So at this point, I've got 4 squared. That needs to be simplified. Again, remember, that means 4 times 4. And 4 times 4 is 16. So I'm just going to cross it out and write 16. So now I'm completely done with step 2, so now I need to check for step 3, which is negative exponents. So I'm looking, do I have any negative exponents? Well, no negative exponents on the top, but I do have a negative exponent on the bottom of -6, and its base is the x. So I'm going to take that base and the negative exponent and move it to the top, and that will make it positive exponent. So on the top, I should have 14, because that didn't move. On the bottom, I should have 16, because that didn't move, and y to the 4th, because that didn't move. Now, when I move my x to the top, it stays as x, and then the -6 exponent becomes a positive 6 exponent. So now I've completed the 3rd rule of negative exponents. I have none of those left. So now I'm on to the 4th rule, which is product of powers rule. So at this spot, I'm looking for the same bases on the same side of the fraction. So when I look at the top here, I don't have any like bases on the top. So nothing to do there. When I look at the bottom, I also don't have any like bases on the top. All right? So I have kind of a choice here. I don't have that rule. So I can either just rewrite it again, or I could just put an X here and say, hey, I didn't have that rule, but I checked for it. Right? So I don't need to rewrite it if I don't want. But if you prefer to just rewrite it, that's fine as well. So then the last rule we need to check for is the 5th rule, which is quotient of powers rule. And this is where we're looking for the same bases on opposite side of the fractions. But also remember, in this rule, we look at the coefficients and we make sure that they're simplified down as well. So I'm going to start with the coefficients and say 14 and 16. Do they have a common factor greater than 1? Well, yes, they do, and that common factor is 2. So I'm going to divide both of those numbers by 2. Well, 14 divided by 2 is 7, and 16 divided by 2 is 8. So I've got a 7 on the top and an 8 on the top. Now I'm going to look at the variables and see, do I have the same variable on both the top and the bottom? Well, no, I don't. So I don't have any like bases on the top and bottom, so those things are going to stay exactly as they are. So the x to the 6th is going to stay on the top, and the y to the 4th is going to stay on the bottom. So my final answer here is 7x to the 6th over 8y to the 4th. All right, well, there's some quick examples for you. There's going to be a second video that follows up with the final 3 examples, so please make sure to check over on that before continuing on to worksheet number 2.